Hi everyone, my name is Erez Berkner and I'm CEO and co-founder of Lumigo. Happy to be here with you at RedisConf. In this session, I'm going to discuss observability of microservices in production. And specifically, we're going to discuss method or ways to monitor and debug microservices at scale. And we're going to take a couple of shots at how Redis is integrated in this concept of microservice observability, and we're going to cover what do you need to run microservices with Redis as one of those in production. So I'm going to cover very quickly the evolution of the modern cloud and the main challenges it brings to production environments. We're going to talk about how do you actually monitor customer-facing failures and how to identify and debug latencies, because these are main things that need to be considered when thinking about microservices. Few words about myself. I'm a developer by heart. I led R&D organizations in different companies. Latest one was Checkpoint, company dealing with security. And in the recent years, I'm dealing all about microservices and serverless as a main focus. And 3 years ago, we founded Lumigo. Lumigo is a serverless observability platform. And when we built Lumigo, we had a concept in mind, allowing organization to be able to build modern application and be able to run it with confidence in production. When we built Lumigo, we built it in DevOps in an agile way in mind. We're 100% serverless in our backend, and at the end of the day, we're running dozens of deployment a day, and the architecture is based on, as I mentioned, as serverless. So a few words about the modern cloud. So when we think about evolution of transportation, this is where I like to begin because for me it's very similar or makes sense to compare to the cloud. And when we think about how we wanted to use transportation, essentially what we need in order to get from one place to another is a way to actually transition, a way to move. And this can be either by buying your own car, going by renting a car, public transportation, or taxi. And let's look at what this means in terms of the maintenance and the investment you need to do. So if you go by buying a car, so you need to own the car, fuel it, navigate to the destination, and drive there. If you go by renting a car, you no longer need the capital expense to buy the car up front. You just rent it, but you do need to take care of fuel, navigate, and get there. If I go by public transportation, somebody else took care of the fuel. I just need to decide which bus station do I go to and navigate and get there. And if I get a Uber, the only thing I need to do is just use the app and tell him where I want to go. And I don't need to take care of all the other stuff I needed before. And as you can see, more and more you're focusing on actually getting there because you don't really want to deal with all the others. And same thing is when you think about the cloud. So when running your application, you could run a physical server. You need to own the server, deploy an operating system, take care of the runtime, scale, high availability, and run your code. Or you can use a virtual machine where you're not buying a server. You can rent it for a cloud provider, for example, but you need to take care of all the others. Containers really take it to the next level because they share an operating system, And serverless really takes this to the extreme where you just upload your code and it just runs. And as you can see, more and more you're focusing on your unique business logic and less about maintenance of the actual application. So when we think about this world, this is what I call the modern cloud, this part over here. Uh, and specifically, um, when I try to split modern cloud, some people call it native cloud or cloud native, I say that there are three different types of applications, type of services. One is the compute, where you have things like AWS Lambda or Azure Functions. Um, I'm mostly going to speak in AWS language over here, just because they're dominant in that market. Um, Fargate, managed containers of different types. Everything that is managed compute falls under the compute, and the associated services like DynamoDB, S3, API gateway. So additional managed services that you can access by APIs are what allows you to perform additional actions. And to add to that, using services like Twilio, Stripe, and Redis, this is what really allows you to, to build end-to-end application which doesn't require really deploying and maintaining servers. So this is what I define as a modern cloud. And while this is great, and this provides great agility and freedom of scaling, and we can talk about the cost reduction and about the ability to scale at different services at different rates, this provides also some challenges. And one of the biggest challenges is how do we actually run this in production? Um, Mainly, as you can see in this survey, the main problem is about visibility, about monitoring, about debugging, and how do I actually test it and make sure I get confidence to run it. So at the end of the day, when we think about it, the services that I mentioned are different. On the one hand side, they're ephemeral, meaning they when you click on something, when something happens, the event actually triggers a set of executions that rise and stop and go to sleep. So there is no server you can actually SSH to, for example. What isn't here, what you don't record while it's running, doesn't exist later. On the second part, it's no longer like three-tier application. It's like tens or hundreds of microservices all working together. And that's challenging to make sense of it all. And the third concept is that you actually don't have server. So, for example, many tools that you used to use in production for monitoring, for debugging, for security, for deployment are no longer relevant because they're using agents which you cannot use in a managed environment. And there are some very interesting way you can integrate the modern cloud with Redis. So this is one example taken from this blog about how you can actually use serverless, specifically here it's AWS Lambda with Redis Cloud. So it's one example, but you can build complex cloud constructs and complex application and still use Redis as the endpoint of for those services from different clouds. So I recommend going and reading this to get some guidance. At the same time, as I mentioned, the main thing that is challenging for running in production is the visibility, is the monitoring. And in order to really understand what's going on in production, especially when you scale, is you need to have uh, visibility and good monitoring tools for that. So there are two parts in monitoring is modern cloud production. One is monitoring the specific services, and I'm going to cover a couple of services, simple services to monitor Redis, but they're going to give you some very good jump start. And the other part is monitoring the microservices, especially in a distributed kind of environment. This is a blog that I would recommend. It's would recommend reading. It covers different monitoring tools for Redis, and it provides nice overview of the tools, open source and non-open source out there. Um, and I want to focus on just shout out for two tools that I found very useful. Redis-stat, which really reminds kind of like VM-stats in the data it provides, in the view, will allow you to see memory and hit and miss figures. So that's a live view of always updated of your Redis status. And another interesting tool is Redis Live, which both of them are open source, by the way. You have the links over here. Sorry, I didn't mention that. You have the links over here. And this is more a visual way, allowing you to see more of a trend, to see that over time. Very simple to use, less like a CLI form, more like in visual, and it allows you to see things like memory over time, the top commands used, and of course the top keys, and you can change it from real time to historical and so on and so forth. Um, The other part of monitoring Redis in a microservice environment is understanding the bigger story. Uh, Understanding Redis is important, but sometimes Redis is not the problem. It's just a service on the chain of serving a bigger purpose. Usually that is the case. And how do you actually monitor customer-facing flows? So in order to really understand what's going on in a microservice environment, you need to have, we talked about monitoring, observability is a bit of a deeper concept of understanding what's going on in your production. And at the very first pillar of observability is getting visibility. So you need to know that once something goes wrong, you will know about it. You will get an alert. You will understand what's going on, and that's the first point. So let's suppose I have here a specific service. This is a Lambda that failed. I need to be able to get alert to be very specific to that service in order to understand that this service is crossing some threshold that I should be aware of. That's a base point. Then we need to understand what is the impact, because microservices are so, I would say, diverse and complex. This might be serving multiple services. So it really matters if this is serving the process payments or the lunch bot that lets you know that lunch is here. And understanding the overall architecture is critical. And this should be done using distributed tracing. Distributed tracing is the concept of allowing you to understand the flow of different requests through your system. And this is especially important when you understand that microservices can look like this. But this is still not enough, because even if you have this architecture diagram, you really want to know about that specific request. And for that, you actually need to have the distributed tracing part, basically building the story of that request. What happens and how did we get here? And now that I understand this is a process payment, this is critical, I need to fix it. But what is the root cause? What is the problem? And this is the third pillar where you need to debug. And when you need to debug, you need a way to be able to investigate. And many times the problem of a specific issue is not within the service that actually fails, but somewhere upstream. And you need a way to go upstream and look at the data. Of course, about the logs, but about the input, the output, stack traces, if there were environment variable and so on, in order to understand what actually happened. So that's about the observability part for microservices. I want to, what do you think about those platforms of serverless, of managed containers, of managed services? Their basic concept of getting the different information from different sources. And when we talk about observability, there are basically three uh, sources that we need to track. One are metrics. Usually cloud providers provide APIs so you can get different metrics for different services. Second are traces, which are the distributed tracing part. This is basically generates ability to track and understand the requests and the different services it went through. And logs, good old logs that need to be correlated because there are so many services, especially at scale. You can implement all of those yourself, by the way. There are great tools to do that. There are some open source tools like Jaeger, and there's some frameworks like OpenTelemetry that basically allow you to implement distributed tracing, allow you to do APIs to get metrics and get the logs and correlate them using a request ID, for example. It's a lot of work, but it's definitely doable, and some companies like Netflix, for example, are doing just that. So I want to take you to our last scenario, and that's how do I actually identify and debug latencies. And for that, I want to show you a live demo. We're going to pause for a second to pray to the demo gods that this will work. And essentially, let's suppose that I experience latency in my environment, and one of the critical parts in microservice environment, because there are so many components, is to understand which service is the one with the hiccup, because it can be one of many services. I'm going to use and show you Lumigo, which is our modern cloud observability system. And this is very easy to connect. It's basically connects to the cloud via APIs, focusing on AWS, via APIs through an IAM role. No code changes for integration. This is agentless, and that's critical in order to really be able to deploy it in managed services. So let's suppose we got an alert about some latency. This is the dashboard. There are some latencies over here, and I want to understand what's going on. Through Lumigo, I can actually see all the services that are in use in the system, and I can tell Lumigo, please sort this by, let's say, by P99. I want to see the bigger bigger latencies. I see the biggest failure of the P99 is Twilio, with almost a second of latency. So if we want to drill down, this is the part where we move from you got something wrong with a specific service, take me to the actual instance. Let's debug, let's go to the root cause. So if I click on this, automatically a query opens and the system showed me all the Twilio calls in the last 7 days that was over 755. And this is sorted by duration, so I see things like 25 seconds, 25 seconds. So I can click on, and this is 1.5. Let's choose one of those and try to understand what happened. And when I click on it, Lumigo is now executing the distributed tracings that we talked about. So this is the heart of Lumigo. Lumigo is able to build the story of that transaction. We can see Twilio over here, but Lumigo basically tells me what happened, where this started from. This is from app purchase, so sounds like a critical flow. And I can now see what happened across the different services. And specifically, if I will go to timeline, because this is where I want to actually understand where am I spending my time, I can see that, yes, the Twilio actually took 1.5 seconds over here. And by clicking on it, I can actually drill down to the details of the request of Twilio. We try to send an SMS to this number, and I can start investigating what happened, or maybe I should contact Twilio, report this, and give them the information about that specific request. And of course, can give them the request ID that I have over here. And so that's about debugging latencies. But what if you're not debugging latencies? What if you want to debug issues? So let's suppose you get an alert about a specific issue. These are the issues that Lumigo identifies for you. But let's figure out, let's choose one of those just for, let's choose this one. And again, the point is taking the observability part from monitoring to debugging. So clicking on a specific failure and getting to the drill down, to the heart of the failure, and building the transaction and being able to drill down to the specific data of the service. Things like show me the stack trace, what was the input for the Lambda, what were the environment variables, what were the outputs for DynamoDB, for example, what table did you query, what was a query. As you can imagine, these are things that are critical to actually get the debugging of microservices across the different services, because you actually go upstream and look at the different data available. So again, I'm showing here our tool, Lumigo, that's a specific tool, but it doesn't have to be. There are different tools from the cloud providers, there are tools of open source, but this is what you should strive to get. The correlation of services, understanding the customer-facing API, getting the data of every service, input and output, etc., and correlation of the logs. So getting out of millions of logs, only the 44 logs that are really related to this transaction. Thank you, demo gods. That worked. Somebody owes me lunch here in the office. So that's what we do at Lumigo. We have a free tier, a community tier. You're welcome to go to lumigo.io and just start an account, and that's for free, up to 150,000 invocations a month. And the last thing that I want to share with you today is an announcement that we have about a new open source tool that we're releasing for microservices with focus on serverless environments. We call it Stackoscope. This was written mainly by Jan Kui, who is our developer advocate and a well-known AWS serverless hero, and with assistance of our VP R&D, who's another serverless hero, and our CTO. And essentially, it's an open source that runs a health check on your serverless environment, allowing you to detect misconfiguration, security issues, and so on and so forth. You can find it over here. Essentially, it's just like install it using like npm install -g Lumigo's CLI, and you just run it by running this command scanner. and you get a complete review of your environment in a PDF style. I think I have it over here. It's an example of what you're gonna get. It's basically going across the different services that you have, the managed services, and letting you know where do you have issues, where do you have misconfiguration, where you can optimize. So just as an example, maybe in a specific environment, I will see that I didn't configure dead letter queue. That's critical for asynchronous queuing. Or maybe I should use an environment of reuse connections because that can boost performance significantly. Maybe my timeout is not enough and I should get timer to be, sorry, duration to be higher. So there are a lot of misconfiguration that this tool identifies, and you basically can get this report. You just install it, run it, and get the report completely free, completely open source. So this is going to be released next week. This is a preview that you're able to see and try out today. So to start and wrap up, if you want to read further, these are the resources that are available. We talked about the microservices and serverless integration with Redis, about the different monitoring tools that we discussed for Redis and the relevant blog, and we talked about the Lumigo observability platform to allow you to do that across microservices. Key takeaways. So I think that maybe the number one thing that I would recommend is to bake distributed tracing into your architecture. The point is that we see many times that this is an afterthought and that become more complex to do. So this is a point to be part of the design of microservice environments from day one. You should use tools in order to do the distributed tracing or develop that on your own, but you should have special monitoring tools specifically for Redis or specifically for other services in order to observe what's going on in a very granular way. The open source tools that are out there should do the trick for you. Another important thing is to make sure that you have the right alerts in place. We talked about granular alerts. Alerts are different in different microservices. So alerts about cache, like cache misses in Redis is very relevant for Redis service. Alerts on Lambda concurrency is relevant for AWS Lambdas. For DynamoDB, you shouldn't look at CPU or I/O. That's not the right measurement. So the world is changing. It's no longer servers that you monitor the CPU, it's services. And a breakdown view of the Redis request is important, meaning when you have many requests from many sources going to your Redis, and we saw this in the map, you need to be able to understand the sources. So not just the fact that somebody's loading my Redis, but who is that someone and where is this load coming from, and then I can actually handle that. So distributed tracing allows you to get this view, to understand who is actually doing that load. With that, I want to thank you very much for this. If there are any questions or any assistance that we can provide, you have my details over here. And I want to wish you enjoy the rest of the sessions and have a great week. Bye bye.